Section 2.5, Inequalities Involving Quadratics, Part 2. Let's take a look at example 3. And I want you to note that I have solved the quadratic inequality, and this is a little bit misleading because this is not really a quadratic inequality. This is a cubic. But when we factor out the GCF, we'll get one of the factors to be a quadratic. So let's go ahead and do this problem. We already know the first step. We want to set one side of the inequality to 0. So let's move the 16x and subtract 16x to both sides. Next, we want to factor the GCF first. Before you even do anything, don't forget your greatest common factor, which in this case, it is x. Next, let's factor that quadratic x squared minus 16. And we get our final 3 factors. Finally, let's find our zeros. Okay, so the first factor gives us 0. The second factor, the x minus 4 factor, gives us 4. And the last factor, x plus 4, gives us negative 4. And if you recall from part 1 of my video, we then write the zeros on a number line. Now, in this case, are we including our zeros? Yes or no? Well, if you said no, you are correct. Because in this case, our inequality is less than 0. We don't have an equal to 0. If we had less than or equal to 0, then we include 0, 4, and negative 4 as part of our solutions. But since we don't in this case, we're just going to write open circles. Remember that the open circles mean that we do not include negative 4, 0, and 4 as part of our solutions. Okay, next, we want to test each interval to see if we get negative or positive solutions. Now, I always like to plug in the numbers that I'm testing into the factored form. So we're going to plug them into the x times x minus 4 times x plus 4. Now, for the first interval, the interval from negative infinity to negative 4, I'm going to choose negative 1,000. For the second interval, I would choose negative 1. For the third interval, I would choose 1. And then for the last interval, I'm going to choose 1,000. Okay. Now, I don't really care about the numerical value. So I just want to see whether my signs are positive and negative. So this is what we're going to do. We're first going to plug in the negative 1,000 into the first factor x. If I plug it in, I get a negative value. Next, I'm going to plug in the negative 1,000 into the second factor, the x minus 4. So negative 1,000 minus 4 is negative again. And then finally, I'm going to plug in the negative 1,000 into the x plus 4 factor. And negative 1,000 plus 4 is once again negative. Now we're ready to multiply those negative signs. So negative times a negative is a positive, times a negative is a negative. Therefore, in the first interval, we're going to get negative solutions. Let's move on to the second interval, the negative 4 to 0. So once again, I'm going to plug in the negative 1 into my first factor, which is just x. So it's just a negative. Then plug in the negative 1 into the second factor, x minus 4. So negative 1 minus 4, that's negative. And then finally plug in the negative 1 into the x plus 4 factor, and that gives us a positive. Negative times a negative is a positive times a positive, we get positive solutions. And then now let's go ahead and plug in the 1 into the x. We get positive. The 1 into the x minus 4, we get negative. And the 1 into the x plus 4, we get positive. So positive times a negative is a negative. And then Negative times a positive is a negative. So now we have negative. And then finally, our last interval, we plug in 1,000. So if we plug in 1,000 into the x factor, we get positive. If we plug in 1,000 into x minus 4, we get positive. And then 1,000 into x plus 4, we get positive. And positive times a positive times a positive is a positive. Okay. Now we call that our interval, our inequality says less than 0. That means we want all the values that give us negative answers. So I'm going to go ahead and shade all the intervals that give us negative values. And we are ready to write our answer. So our answer is negative infinity to negative 4. And I'm just reading the highlighted parts of the interval or of the number line. Now, remember that negative 4 is not included. That's why we have an open circle and we use parentheses. Union parentheses 0 to 4. And that is our final answer. Now, I did tell you in the first part that I was going to show you a shortcut. So here is my shortcut. So I'm going to actually move to the side over here so you can see the shortcut. Okay. Let's do an example. It's easier to show my shortcut if I do an example, and then we'll go back to example 3. So I'm going to go ahead and factor this just like we would an inequality. And we get x minus 2 quantity squared less than or equal to 0. And here my 0 is actually just 1 0. I only have 2. We're going to write our 0 on the number line. Since it's less than or equal to 0, I know that 2 is included. Okay, finally, I need a number to plug into the x minus 2 squared. So this is what I'm plugging my values into. So let's say I plug in negative 1,000. Well, negative 1,000 minus 2 squared is positive. Okay. Now, instead of plugging in a number between 2 and infinity, I'm actually just going to take a look at the power of my factor. Now, this 0 came from the x minus 2 factor, which has an even power. If the power is even, then the sign of the next interval stays the same. That means that without doing any calculations, I know that my next interval is positive. So this is where I'm at here. This is my next interval. It's positive because the power is even. So if you think about that for a second, if the power is even, the sign is not going to change, right? So let's say that my solution, the previous interval, was negative, then so will be the following interval. Okay, so the power is even, the sign is changes. Now, if the power, by the way, let's finish this problem real quick because I didn't finish it. Okay, so in this case, what do I shade? Which part of my intervals do I shade? If you said nothing, you're correct because the inequality says that we want all the solutions that make this inequality less than or equal to 0, but we have no solutions. So we don't have a solution here, actually. So it's the empty set, meaning there's nothing there, no solution. Okay, let's actually go back to our example 3. Okay, now I know we already have the answers, but I'm actually going to delete those. And I'll show you why in a second. I want us to practice the shortcut. Okay, so I deleted my answers. Now I'm going to leave the first interval because I do actually need that one. Okay, so let's look at negative 4. Where did negative 4 come from? Which factor? If you said x plus 4, you are correct. Now, the factor in the x plus 4 is odd because, the power, odd. There's an imaginary 1 there. Because the power is odd, then I know that the sign for my next interval is actually going to change. So we went from negative to positive. Now let's take a look at the 0. Where did that 0 come from? Which factor? X. Again, the power is odd. Since the power is odd, the next sign is going to change. So remember, only when it's even, the signs stay the same. Finally, where did 4 come from? Okay, if you said x minus 4, then you are correct. And again, the power is odd, so the sign changes. And that's a really short way to do this problem. And you get the same answer. So again, remember, if the zeros came from a factor in which the power is odd, the signs change. But if the power is even, the signs stay the same. And if you still have questions on that, I can explain to you how to do that in our next Zoom class.